Hello, this is Math 111 Applied Calculus Exam 3 review. First question, you're given a function. It's given as a graph, and question A says, find all intervals where f prime is less than 0. As you know, f prime less than 0 implies that the function is decreasing. Now, one thing that you have to be careful when you determine whether a function is increasing or decreasing is that you should always read from left to right. See, sometimes when you see a graph, you end up reading from right to left, and this portion of the graph, in that case, looks like it's decreasing, but that's not. It's not decreasing because you're supposed to read from left to right, so it's increasing in this portion. Over here, it's decreasing, so indeed, this would be a case where f prime is less than 0. And here it's increasing again, so it looks like the only place where f prime is less than 0 is the interval 0 to 1. Okay, interval from 0 to 1. Now find all critical numbers. What's a critical number? Critical numbers are numbers where the derivative is equal to 0, just like here when you have a flat horizontal slope, or when you have a point where the derivative does not exist. So over here you have a sharp turn, so that's a place where f prime doesn't exist. So we know that f prime is 0 at x equal to 3, and f prime does not exist at x equals to 0 because when x is equal to 0, you see a sharp turn. So these are critical numbers. Does the function have any relative extrema? Yes, it does. A relative extrema is a point where it is higher than the nearby points. So over here you can see that it's higher than the right and higher than the left. So x equal to 0 and y equals to 3. So actually 0, 3. This point is a relative maximum. Now on the other hand, you can see that this is kind of low. It's lower than the other neighboring places, but the problem is this is an open circle, meaning that the point itself doesn't exist. So you can get closer and closer to this lowest point, but you can never reach it. So in that case, you don't call this a relative minima because there is no such a point. There's always some point less than the other one, because as you go closer and closer to that, you can always find something that's even closer than this target point. So there is no place that you can say it's definitely this point. And neither is this one a relative minimum because this while this is lower than the left part of this graph, when you go slightly to the right, you see that this portion is lower than this dot. So this is not a relative minimum. So there is one relative maximum, but no relative minimum. Okay, so that answers C and D. Question 2. You're given a piecewise function, and the first thing that you have to do is you have to find all critical numbers. And second, you have to find for each critical number, use the first derivative test to identify whether it is a relative minimum, relative maximum, or neither. Okay, so let's try to draw the graph. It's this side. Well, this is, you can factor this as negative x. Negative x is a common factor, so after factoring out negative x, you have x plus 1, which gives you that x equal to 0 and x equal to negative 1 are the two places where it crosses the x-axis. Okay, I mean, how do you find the x-intercept? You set y equal to 0, right? If you set this equal to 0, then you end up saying x is 0 and x equal to negative 1. So those are the points where it has an x-intercept. And because it's a parabola, x squared, with minus in front, so it's an upside down parabola opening, it's a parabola opening down, so it must be a graph that's like this. Now, we have to be careful because this is not the entire graph. We can only use the part where it's on the left side of 0, because at x equal to exactly 0, what happened? It's it follows this, but right after x equal to 0, it follows another function, 4 minus x. So we should actually erase this part here, which is on the right side, and we just have this part. Okay. Now, what about 4 minus x? Well, this we know that it's a line with slope -1 with y-intercept 4. So if this is 4, and slope -1, so it's going to go down like that. Okay. And because over here x equal to 0 itself is not part of the graph, you should put an open circle here. Okay. So we put an open circle, it comes down just like that. Okay. All right, in that case, first, what are the critical numbers? Critical numbers are when f prime is 0 or f prime does not exist. And over here we see that at somewhere here, I don't know exactly where, but there's a point where there's a horizontal tangent line. Okay. And then there's another point here where the graph is not continuous. Remember, when the graph is not continuous, if it's broken, then it cannot be differentiable at that point. So that will be another point. So f prime does not exist when x is equal to 0. And to figure out when f prime is equal to 0, we should actually differentiate this and set it equal to 0. So if you differentiate, we get f prime equals to -2x minus 1. You set this equal to 0. X squared differentiates to 2x. X differentiates to 1. So you get this. And then if you solve this, you get x -2x equals to 1. Divide by -2, you get x equal to -2, -1/2. So these are the points where you have a critical number. -1/2 is when you have a horizontal tangent line, and x equal to 0 is when you have a broken place so that f prime does not exist. Okay. Now for each critical number, use the first derivative test to identify whether it is a relative minimum, relative maximum, or neither. Okay. We draw the number line, and then we mark those points when the f prime is 0 or it doesn't exist. So mark those critical numbers. One is -1/2, another one is 0. So we have these two critical numbers. And then what you want to know is whether f is increasing or decreasing. Okay? So by looking at the sign of f prime, we can determine if f is increasing or decreasing. So we pick test points. We pick here 1, I guess -1/4, and over here we should be using -1. Okay, now what is f prime? F prime of x is simply the derivative of these two. So this is -2x minus 1, as we have said before. And then if you differentiate the second function, it's just -1. That's for x bigger than 0. Another thing that you have to notice is that here I didn't include 0 because f prime doesn't exist at 0. Okay? I explained why here, right? So f prime is a function where f prime of 0 does not exist. There's no value when x is equal to 0. Right. When you have -2x minus 1, that's valid for this left side. When you plug in this value, test value -1 here, if I plug in -1, what do you get? Negative 2 times negative 1, that's positive 2. 2 minus 1 gives you positive 1. So we know that if I plug in negative 1, you get a positive value. Okay. Positive value. And then if I plug in negative 1/4 here, 1/4 times 2 is equal to 1/2. Negative times negative is positive. So if I plug in negative 1/4, it gives you negative 1/2, negative 1/2 minus 1. No, positive 1/2. Positive 1/2 minus 1 will give you negative 1/2. So plugging in negative 1/4 gives you negative. And if you plug in 1, 1 is bigger than 0, so you should be plugging in here. And when you plug in 1, regardless of the value you plug in, it's always negative 1. Slope is always negative 1. Now these plus or minuses of these sampled values actually tell you the sign of f prime for the entire interval where each of these points are included. So because I know that at negative 1 f prime is plus, I know that f prime is plus from negative infinity to negative 1/2, which means that in that interval f is increasing. Okay. And then f is decreasing after 1/2 until 0, and then over here it's decreasing again. Okay. Now, when the graph is continuous, the first derivative test can be easily used without much thought. See here, the graph is continuous here, right? So it went up and then down. So what kind of point is this? This is a relative maxima. Okay. Now over here, what you have to do is here, the graph seems to be broken. Graph is actually broken if you knew the actual graph. So it's really hard to judge what's going on here without actually seeing the graph. So although this said use the first derivative test, you should be careful and go back to the actual graph and see what's going on in here. So in B, we see that the critical number x equals to negative 1/2 actually gives you relative max. Now, what about the critical number x equal to 0? The critical number x equal to 0 is this place. Now, is this less than the left side of the graph? It is, right? It's lower than the left side. What about if you choose a little bit to the right? If you go slightly to the right, the values are all above this value. So you do see that this, in fact, is lower than the neighboring values. So this is really a relative minimum. Okay. So in a sense, this question shows you when you have to be careful when you use the first derivative test. Okay, question 3. Find all the extrema, absolute extrema of a given function over some given interval. And absolute extrema means that you just want to know the highest value and lowest value of the given function over some interval. And it's actually quite easy to determine such a question. You just have to first find critical numbers, and then step 2, evaluate at critical numbers and also endpoints of the interval. And step 3, figure out which is highest, which is largest and smallest. So just follow these 3 steps and you just have the answer. So let's try the first question, A. If you differentiate, this is 3 comes down and you have to subtract 1 off of 3, which is squared. 2 comes down, 2 times 6 is 12, so if 12 times x. You set this equal to 0 because we want to find the critical numbers. Because this function is continuous, and also we know that polynomials are always differentiable, the only time when you have a critical number is when f prime is equal to 0. For b and c, you'll see that these functions will have places where the derivative does not exist, so you have to be a little careful when finding critical numbers, because you may have a critical number where the derivative does not exist. Okay, let's factor out negative 3x because it seems to be a common factor. So negative 3x squared is negative 3x times x, and negative 3x times negative 4 is positive 12x, right? And if you want to figure out when this is 0, x is 0 or x is 4. So these are the critical numbers. The endpoints are negative 1 and also 5, so we have to evaluate the function at these 4 places. Okay. F of 0 is 0 because if you plug in 0 here, they're both 0. F of 4, let's see, f of 4 is negative 4 cubed plus 6 times 4 squared, which is 32. F of negative 1, if you plug it in here, negative 1 cubed is negative 1, negative 1 times negative is positive 1, and then when you plug in negative 1 to here, you square it, you get positive 1, and you get 6, so you get 1 plus 6, which is 7. And then f of 5, that's a huge number, negative 5 cubed. 5 cubed is 125. And then 6 times 5 squared, so that's 150. So you get 25. And if you compare the values in here, the lowest value seems to be f of 0 equal to 0, and the highest value is f of 4 equals to 32. So the answer for that case, so for A, the answer would be 0, comma 0 is relative minimum. Actually, not relative, we're looking for absolute minimum. And we have 4, comma 32. That is the absolute maximum. Now let's try to do the second question, B. You first have to find the critical number, so f prime of x equals to 0. Constants differentiate to 0, so we have that. And this one we have to use the power rule, so it's 2/3 comes down and you have to subtract 1 off of 2/3. 2/3 minus 1 is negative 1/3. Now, when you have a negative exponent, you should interpret it as 1 over the positive exponent. And 1/3 power is same as cube root, so you have 2 over 3 times cube root of x. Now, when is f prime equal to 0? Well, never, because for a fraction to equal to 0, the numerator has to be 0, but numerator is 2, so that can never become 0, so never. However, f prime does not exist at one point. Where is that? That's x equal to 0. Because if you have x equal to 0, you have 0 in the denominator, and therefore you have a fraction whose denominator is 0, and this is undefined. Okay. Notice that x equal to 0 is in the domain of this function. 0 is included in negative 1 to 27, and also because this is 2/3 is a positive exponent, you can plug in 0 without any problem. 0 to 2/3 power is just 0. Okay, so we do know that this is the only critical number, and added to this we have the two boundary points, negative 1 and 27. So let's try to evaluate this. So this part was trying to find the critical number. And now let's try to evaluate f. So what's f of 0? F of 0 is 3 minus 0 to the 2/3 power, 0 to any power 0, so you have 3 minus 0, which is 3. F of negative 1, let's see, 3 minus negative 1 2/3 power. We're just simply substituting x by negative 1, and when you do this, make sure you have this parenthesis. If you don't, you're going to end up with the wrong answer. Now, when you have 2/3, this means in terms of radicals, it's cube root of negative 1 squared. So maybe you forgot this, so let me write down the formula. If you have a to the m over n, that's equals to nth root of a to the mth power. Okay, so we use that, and we know that negative 1 squared is positive 1, and what's cube root of 1? It's just 1, so 3 minus 1 is equal to 2. Thirdly, we have f of 27, which is 3 minus 27 2/3. Now we could evaluate this using the same technique here, but since 27 is 3 to the 3rd power, actually there's a better shortcut to evaluating this. 27 is 3 to the 3rd power, and you're taking 2/3 power, and we know that when you have a to the m to the nth power, that's same as a to the m times n, and using that formula, we know that we have to multiply these two. 3 times 2/3 is 2, because when you multiply, these two cancel each other, so we end up with 3 squared, which is 9, so you have 3 minus 9, which is negative 6. Okay, so what's the largest? There's 3. That's the absolute max. What's the smallest? Negative 6. That will be absolute minimum. So we can write down the answer here. Answer for B is that you have 0, 3 as absolute max, and 27, negative 6 as the absolute minimum. Okay, now let's try question C. Now question C is a bit hard to solve just by using algebra, so it's actually better if you try to solve by drawing the graph. I mean, after all, we know that absolute values are like a V-shaped thing, and also when this is equal to 0, this x minus 2 is equal to 0, we know that it has this vertex. So this vertex is when this absolute value becomes 0. That's when the direction suddenly changes, right? Another thing is that because you have a minus in front of the absolute, you will end up with minus of that will be like upside down, and we just have to know which point this is, and it's going to be this point where you have this sharp turn will be when x is equal to 2, because that's when this is 0. So think about it this way. You have f changing its direction. The vertex of this V-shaped thing must be at 2. So if we evaluate at 2, you have 2 minus 2 minus 2, which is 2 minus 0, which is just 2. That tells me that the graph must pass through 2, 2, and we're ready to draw the graph. So here's 2, here's 2. There must be the there must have a vertex here, and we're trying to draw an upside down one, so we just draw upside down, just like that. Okay. Now, if you plug in more points, you're going to get a better picture, but that's not really necessary. Anyways, you have the interval given as 0 to 4, and we have to figure out when this graph has a critical number. Now, because it's a straight line, there's never a point where you have a horizontal tangent line. There is a point where f prime is not defined. See, this sharp turn makes f prime undefined. F prime does not exist at this sharp turn, so the critical number will be 2. Because this happens, x equals to 2, so that means that 2 is a critical number. Okay. Once you have found the critical number, then the next thing you do is attach the two endpoints. So we have 0 and 4 as the two endpoints, and 2 is the critical number that's in between. And now we have 3 points, 0, 2, and 4, where you have to evaluate the function, and you have to figure out when it gives you the minimum and when it gives you the maximum. First, f of 0. F of 0 is 2 minus 0 minus 2, and that's 2 minus absolute value of negative 2. Absolute value of negative 2 is positive 2, so you have 2 minus 2, which is 0. F of 4 is 2 minus absolute value of 4 minus 2, and then 4 minus 2 is 2, and you end up with 2 minus 2, which is again 0. Okay. And we already have f of 2, so now we can compare 2, 0, and 0 and figure out which is the maximum, which is the minimum. I see that this is maximum, and these are both minimums. Okay. And that can actually happen. You may have two absolute minimum if you have the same minimum. So there's a tie in the minimum values. In that case, both will be considered as absolute minimum. So the answer will be, for part C, the answer would be 0, 0, and 4, 0 is absolute minimum, whereas 2, 2 is absolute maximum. Okay, question 4. For each of the functions below, find all relative extrema and also the intervals where the function is increasing or decreasing. So this is again about the first derivative test. You differentiate, and all these functions are either polynomials or polynomial times exponential functions. They are all differentiable, so you don't have to worry about finding points where f prime does not exist. You only need to figure out when f prime is equal to 0. Those will be the critical points. Okay, the derivative of the first one is 6x squared, because 3 comes down, 3 times 2 is 6, 3 minus 1 is 2, 6x squared, minus 2 times 15, which is 30x, minus 36. And I see that 6 is a common factor, so if I factor 6 out, you have x squared minus 5x minus 6. And I can further factor this as, well, 6 and plus 1. So x minus 6, x plus 1 is the factor of the previous one. Okay, now I want to know when f prime is equal to 0. That means I need to know when 6, x minus 6, x plus 1 equals to 0. So I need 6 equal to 0, or x minus 6 equal to 0, or x plus 1 equal to 0. Well, 6 is never equal to 0, so that's out of the question. X could be 6 for this case, and x could be negative 1 for this case. Okay, so you have two critical numbers, 6 and negative 1. Once you find the critical numbers, you are to put them on the number line, which is negative 1, 6, just like this. And this time the graph is continuous, so you can just figure out when the function is increasing or decreasing to figure out the relative maximum and relative minimum. You don't really need to know the entire graph. Okay. All right. So let's see. You have to pick test points. So I'm going to pick -2 here, 0 here. Just pick something that's really easy to calculate. And then we plug in those values into f prime of -2. And when you do that, it's easier if you use the factored form to evaluate. So you can put 6 times -2 minus 6, -2 plus 1, which is 6 times -8 times -1. And it's positive. 6 times 8 is 48. And actually, the value is not that important. You just need to know whether it's positive or negative. And that's all we care. And it is positive. F prime of 0. When it comes to plugging in 0, it's actually easier to plug it into here because 0, 0 makes it 0. The only thing that you get is -36. So that's negative. F prime of 0 is negative. F prime of 7. Again, let's use this factored form. 6 times 7 minus 6, 7 plus 1, which is 1, then 8. 1 times 8 is 8. 8 times 6 is, again, 48. So this is plus. So these are the signs of f prime. What does that mean for f? Well, that means f is increasing, because f prime is positive. And then here, f is decreasing. And then over here, f is increasing. Okay, so here is at least the interval. So part of the answer goes like this. Answer: f is increasing on here and here, right? The first interval is from -infinity to -1, and 6. Let's not use the sample values. That's just a sample point from this interval. The interval actually begins at 6. Okay, so from 6 to infinity. Also, f is decreasing on this interval, -1 to 6. Okay, now what about relative max and relative min? Well, it's increasing and then decreasing, so this is like a relative max, whereas it's decreasing and then increasing, so this will be a relative minimum. Okay, and that will be the part of the answer. So answer will be relative max would be at -1 comma, let's see, if I plug in -1 here, 36 plus 14 is 15, 50, then it's 35, 35 minus 1, 33. Okay, so relative max is -1 comma 33, and relative min would be, it's going to happen at 6. So if I plug in 6, oh, that's a lot. Let's see, 200. Oh, so these two will, so 216, 14, 230, 36 times 15, 180 times 3 minus 540. Okay, so it'll be 540 minus 230, and then, okay, I'm just doing this in my head. You can do this easily when you have a calculator, right? So you get 310, but that should be a negative. So relative minimum should be 6 comma -310. Now the reason I'm doing this is because the definition of a relative max and relative min, these are points on the graph. So you need to provide coordinates, not just the x coordinates. You need to provide both coordinates. Okay, let's go for question B. We have f prime of x equals to, well, we have to use a product rule because it's a product of negative 2x and then x minus 6 squared. So negative 2x times x minus 6 squared prime. You could also expand this and then differentiate, but that's going to take more time. You'll find this easier. Okay, so you have negative 2 x minus 6 squared plus negative 2x, and this x minus 6 is nested inside, so you have to use the chain rule, which says 2 comes down and you have to pull x minus 6 outside and differentiate. That just gives you 1. And the nice thing about doing it this way is that you immediately see that x minus 6 is a common factor along with negative 2. So why not factor out negative 2x minus 6? That means from the first term you have x minus 6 remaining. If I take away negative and 2 times x minus 6 away, you're left with 2x from the second one. So you end up with negative 2 x minus 6. X plus 2x is 3x minus 6. Alright, now, when is f prime equal to 0? That means you have to know when negative 2 x minus 6, 3x minus 6 is equal to 0. Negative 2 equal to 0, well, that never happens. X minus 6 equal to 0, that gives you x equal to 6. 3x minus 6 equal to 0 gives you 3x equal to 6, and then x must be 6 divided by 3, which is 2. So 2 and 6 are the critical numbers. Put that on the number line. Test points, I guess 0 is a good number. 3, then 7, smaller the better. Okay, when you plug in 0, well, f prime of 0 you should be using here. That gives you negative 2 times 0 minus 6 and 0 minus 6 again. So it would be positive 36 times negative 2, which is negative 72. So it's going to be negative. F prime of 3 would give you negative 2 times 3 minus 6 is negative 3. I'm plugging into this factored form. Factored form is always the easiest to use. Okay, and then 3 times 3 is 9. 9 minus 6 is positive 3. So you end up with positive 6 times 3, which is positive 18. So it's plus here. Okay, and then f prime of 7 is going to give you negative 2 times 1. 7 minus 6 is 1. 7 times 3 is 21 minus 6 is 15. So you have negative 30 as the answer. So it's negative here. Okay, that means since f prime is negative, positive, negative, that means f is decreasing, increasing, and then decreasing. Alright, so this means here it's a relative minimum, and over here it will be a relative maximum. So let's write down the answer now. Answer. You have, let's see, 2 comma, we know at 2 it has a relative minimum. 2 minus 6 is negative 4, squared is positive 16. 16 times 2 times 2 is 4 times 16. So negative 64 is the y value for x value positive 2. That's the relative minimum. Okay, now for 6, when you plug in 6, well, 6 minus 6 is 0, so it gives you 0 as the y value. So 6 comma 0 is the relative maximum. And increasing on what interval? From 2 to 6. From 2 to 6 it's increasing. And then decreasing on negative infinity to 2. And you put the union if you have more than one interval, right? And then 6 to infinity. Okay, so that is the answer.